Hello, and welcome to another Algebra 1 lesson. This is lesson 9.6, Solve Systems of Nonlinear Equations. Solving nonlinear systems by graphing. The method for solving systems of linear equations can also be used to solve systems of nonlinear equations. A system of nonlinear equations is a system in which at least one of the equations is nonlinear, meaning it is not a line. When a nonlinear system consists of a linear equation and a quadratic equation, the graphs can intersect in 0, 1, or 2 points. So the system can have 0, 1, or 2 solutions. It all depends on how many places they intersect. Intersection points are the solutions. Example 1. Solve the system by graphing. Use Desmos.com or a graphing calculator. Y equals 2x squared plus 5x minus 1, and y equals x minus 3. A system of equations is always more than one equation. So here we have two equations. We have to find the point of intersection. If you open the graphing calculator on Desmos and type in your two equations, you then look at your graph and find that point of intersection. So we need to know what point is that. Back 1, down 4. So that's -1, -4. That is the solution to our system. Now, if we use this for x and y in each of the equations, that gives us a way to check it. So find the intersection xy, check the point by substituting the coordinates into each of the equations. So if we put in a -1 for x, we should get a -4 over here. Just want to make sure it makes both equations true. So I'm going to type this side into my calculator and hit enter and hope it comes up -4. If you're using a graphing calculator like a TI-83 or 84, be careful because a minus and a negative are different buttons. The negative button is a white button under the 3. The minus is a yellow button over on the far right side. So when you hit enter, you get -4 equals -4, so that checks out. Then we put the x and y into the second equation to make sure that one works also. Does -4 equal -1 minus 3? Yes, it does. So it makes both equations true. So this is our answer. So we're really just looking for that intersection point. That's how we can solve by graphing. Let's try some more. Make sure you open a tab to Desmos. Write down the two equations for problem number 1. Then we're going to have to graph them on Desmos. So when you're opening Desmos, you want the graphing calculator. You have a keyboard down at the bottom that you can open to type in your equations. Helps if you write down your equations. X squared plus 4x minus 4. And go to the next line, type in your second equation. Close your little keyboard and whoop. You can zoom in or out as needed. I'm going to zoom in a little bit. It's hard to tell where that intersection point is. Looks like it's here. But this is why we also need to know how to check it. Okay, -1, -7. If I put in a -1 here, that gives me -2. -2 minus 5 is -7. Oh, good. Makes this one true. Should make this one true. We're going to write this down. -1, -7. We have 1 point of intersection. All right, graph the next one. Find your point of intersection. On your mark, get set, go. Okay, here's the graph of number 2. They don't intersect. So what do we write for our answer? No real solution. Actually, there's just no solution. All right, type in your 2 equations for number 3. For the fraction, you'll just do 1 divided by 2, and then use the over arrow to get out of the fraction before you type your x squared. There's 2 answers for this one. See if you can find them both. I'm not going to graph this one for you. I need you to graph it. Check your answers with mine. All right, hope you're getting the hang of Desmos. That was solving by graphing. Now, let's get ready to solve by substitution. You can always solve systems by substitution or elimination. We can use either method. For the most part, I'm going to use substitution. That's my favorite. We have 2 equations. This second equation says y equals -3. Well, we can just put that into the other equation. So negative, take out the y, equals -3x plus 6. Put in the -3. Now we have just an x and we can solve. Solve for x. All right, x is 1, y is -3. So we have the point 1, -3. All right, let's try the next one. Y equals this algebraic stuff. So y equals stuff. So we can substitute that in for y into the other equation. So we're going to write this equation, the 5x plus 4y equals -17, but take out the y, put in 2x minus 1. Notice our equation only has x's in it, so now solve for x. Right, we have x is -1. We don't have y yet. This other one gave us y, and problem 2 did not. So now we have to go find y. So y equals 2x minus 1. But we have a number for y now, so we can put that in. So we'll go over here. Y equals 2x minus 1. And y equals -1. So our answer for number 2, put the x and y together, -1, -1. All right, one more to solve on this page. Okay, we're working on number 3. Let's solve this one by elimination. Elimination is where you stack up the two equations and add them together, but you want either the coefficients of the x's or the coefficients of the y's to be opposites. So here we have a -7y, and here we have a +1y. So I can turn this y into a +7y if I multiply this entire equation by 7. So I'm going to leave the first equation alone. But multiply the second equation by 7, all of it. And we can stack them up, add them up. So if we add these together, we get 11x. The y's cancel out. 3 minus 14 is -11. Finish solving. Divide both sides by 11, we get -1. Now that we have x, go back and find y. Use either one of the original equations. X is -1, y is +1. Pair up your answers as an XY pair. And there's our answer to the system. Now, these 3 problems were all linear systems. They were all lines. That is the stuff that we learned how to do in 5.2 and 5.3, way back in Chapter 5. But the algebraic procedures that you use to solve nonlinear systems are similar to the procedures that you use to solve linear systems. So we're going to use these skills and apply it to our nonlinear systems. All right, solve the system by substitution. We're going to stick with substitution. Both equations are y equals stuff. This one has an x squared, this one does not. But y equals this stuff, so we can put this stuff in for y into the other equation. Now we have an equation that only has x's and no y's, so we can solve. Because it's quadratic, we want to get it into standard form. So we want 0 on one side, everything else on the other side. How do we cancel out a negative 2x? Yep, add 2x. And I'm going to do two things at once here. How do I cancel out a positive 3? Subtract 3. All right, as long as whatever I do to the left side of the equal sign, I also do on the right side. I also lined them up with their like terms so that's easier. 0, 0 equals x squared plus 3x minus 4. It's in standard form. Now we can solve by one of those 5 ways we learned how to solve quadratic equations. Factoring and quadratic formula are my two personal favorites. Factoring or quadratic formula. X equals the opposite of b plus and minus the square root of b squared minus 4ac all over 2a. We can use that formula, but if we can factor this, we can avoid it. Do you see two numbers that multiply to be negative 4 and add to be 3? I do. So let's solve this one by factoring. That would be x plus 4 times x minus 1. Double check. 4 times negative 1 is negative 4. 4 plus negative 1 is positive 3. Awesome. Okay. Now, write down each one of the factors equal to 0 and solve. Subtract 4 from each side, we get x equals negative 4. Here we would add 1 to both sides and we get x equals 1. But we're not done yet. We have 2 answers for x, so now we need 2 answers for y to go with them. That means that these 2 equations intersect in 2 places. If we were to graph them, there's 2 points of intersection. So we need to find the y's. When x equals negative 4, what does y equal? I'm going to use this second equation. Y equals negative 2x plus 3. I'm taking out the x. Put in your x. So what's y? Negative 2 times negative 4 is positive 8. 8 plus 3 is 11. So one of our answers is negative 411. And now we find the other one. When x is 1, what's y? Using that same equation, the y equals negative 2x plus 3. Take out the x, put in the 1. Negative 2 plus 3 is 1. So that gives us our other point. So our answers are, this one was 1, 1. And then the first one we found was negative 4, 11. So we found the 2 points of intersection algebraically without graphing. So we can solve the system by graphing, we can solve it by substitution. There could be 0 solutions, no solutions, 1 solution, 2 solutions, so you've got to watch out for that. Approximate solutions of the system to the nearest thousandth. Look at this equation, 3 to the x power. We are not going to do this one algebraically. So let's go to Desmos, write these equations down. And then go to Desmos. Graph it, find your points of intersection, and notice we're looking for the nearest thousandths place. So when you type in your fraction, you always want to use this over arrow to get out of your fraction. There's one of our equations, type in the other one. 3 to the x power. Okay, so we have, here's our squared button. This a to the b button, I'm going to click that one. It'll move our little cursor up to the exponent spot, and then we'll type in our x. So that's an exponential curve, like exponential growth that we've studied previously. And then we have a parabola, and we need this one point of intersection. Click on it. Desmos is really good about letting you click on points of intersection and x and y intercepts and leaving that number there. If it's in your way, you click it again and it goes away, typically. Go away, go away, go away. There. We want this one. So we write down our answer. Double check what did they want us to round to. Thousandths place. So we have tenths, hundredths, thousandths. So that's 3 decimal places. 3 decimal places. So our answer is 1.194 is our x, and 3.713 is the y. Ta-da! All right, that's example 4. Solve the system using any method. All right, this is your exit ticket. Give it a try. You can use graphing or substitution. On your mark, get set, go. Did you get it? There's 2 answers. Did you use graphing or substitution? I use graphing. You could solve by substitution. But there is 2 answers. Found them both. Desmos is amazing. All right. Thanks for watching. Have a great day. Get to work on your big ideas assignment. You can work on 9.6 or some of your overdue assignments. But this is our last lesson in Chapter 9. So your Chapter 9 test is coming soon. So make sure you're getting your work caught up. Remember, you have to submit all of your assignments before the test. All right, have a great day. Thanks for watching.